Okay, so on 7.10, we're not doing the ready. Okay, sorry again, the video is a little late. So if you look on Canvas, you should see that it's not due till like the 29th. Okay, so we're not doing the ready. This is finding the center of a circle. It says use chords. So if you guys remember, I think we did this like on the first one of the first lesson of the chapter. You made 2 chords. Okay, so just a reminder, we're not doing the ready, but I just want you guys to know what a chord is. Okay, it's any 2 points on a circle connected with a straight line. That's a chord. Okay, so for this one, what you would do is you would make any two chords. Okay, I'm just make it so it's random. Okay, so 2 chords. You would find the perpendicular bisectors of each one with a compass, which is why we're not doing it. Okay, so like perpendicular bisector of that one, and then perpendicular bisector of that one. Okay, and they should cross somewhere. Alright, they would cross in the center of the circle. Alright, there's a video of that too on my YouTube channel from the very beginning. Alright, it's 3, 4, and 5. 3 talks about how you did it, so that's what we just talked about. 4 talks about central angles and inscribed angles, and about what the relationship is. Okay, so again, I just want you guys to remember this. Okay, this is like the main idea of this chapter. Okay, so let's again say this is the center. Okay, if we made a central angle like this, so an angle where the vertex is in the center of the circle, that's what a central angle is. Any central angle has a special relationship to an inscribed angle. Okay, so this angle, this green angle, is inscribed in the circle because all 3 points of it are on the outside of a circle. So in other words, it's kind of like inside of the circle. It's inscribed inside of it. The red one is a central angle because the angle goes to the center of the circle. Okay, and so there's the thing we did all chapter, this is pretty much half of the chapter right here, is that the red angle is twice the green angle. Okay, so just so we remember this, because this is going to be in the quiz when you take it for this chapter. The red would equal 2 times the green in this one. Or you could also think about it as the green is half of the red. Either way. Alright, so that's just like the main idea. One of the main ideas that we remembered from the chapter. Alright, but again, we're not doing the ready. Okay, so the set and the go should be pretty easy. You're just finding surface area and volume again. Okay, remember the surface area is the area of all of the surfaces of the shape. So for number 6, there's the front and the back surfaces. Okay, those would be 9 by 8. So it'd be 9 times 8, that'd be 72. Okay. The left and the right sides would be 9 by 20. Okay, so to find the area of each of those, 9 times 20, whatever that is. Remember, there's 2 of them. Don't forget, you have the top and the bottom. That should be 8 by 20. Okay, and you got 2 of those. Okay, add it all together. And then when you get to like 7, it's going to say, okay, now do all the same stuff for a prism that's enlarged by 4. Okay, so that means that for number 7, this side here is going to be, this side is going to be 4 times that size. So instead of 9 feet, it's going to be 36 feet. This one, instead of 8 feet, 8 times 4, 32 feet. This one, instead of 20, 20 times 4, 80 feet. Okay? And then you just do all the same stuff again. And remember, volume is just length times width times height. So to get the volume, you would multiply that times that times that. Alright? Should help you. This should be good for 7 and 8. Whoa, did they skip a number here? Yeah, oh no, 9's over there. Okay, so 7, 8, 9 should be all the same. And then here, surface area and volume. Remember here, volume is pi r squared times h. Okay, and then the surface area, there's 3 surfaces here. There's a, oh, you have the top and the bottom. Okay, so those 2 areas will be circles. That's pi r squared. And then you have the area of the side of the soda can. So remember from a previous problem, if you cut a soda can down the side long ways, I guess you'd call it hot dog style, and unrolled it, it would make a rectangle. The rectangle would be 8 feet tall. It's a pretty big soda can. 8 feet tall. But now keep in mind that the bottom of this distance here, is going to be this entire circle. Well, you got the top and the bottom, but it's the same distance. It's going to be this circle, but it's going to be like unrolled into a straight line, as if you were to like cut a circle and form it into a straight line. Okay, so to get this distance here, you're going to have to find the circumference of these circles. Circumference is 2 pi r. So that should be pretty easy, I think, for this one. 2 times the radius is 3 feet, so this distance would be 6 pi, because it's the radius times 2 times pi. So to get the area of this surface, it would be 6 pi times 8. That'd be 48 pi. Okay, then you got to do the top and the bottom. Alright, that should help you for 12 and 13 also. And then the go should be review. Okay, so I'm not gonna really talk too much about any examples here for the go, but if you guys want to do we can do a live session and we can do every single one of these, because these radian measures, this right here, I'm not gonna do a video of it, but this right here, what we're doing here is a big part of next year. Okay, you're going to be working next year almost entirely, at least like half of the year, you're going to be working in radians. Okay, the other half you're going to be working in radians and degrees. Okay, so the radians aren't going away, and they come back in calculus too. Okay, so make sure you guys send me emails or whatever, post a comment on this video, whatever you want. Let me know if we need to do a live conference for the go. Alright? Other than that, I know it's not due till the 29th, but try to get it done as soon as possible and email me with questions.